So this video is on how to use the spdf block system to write electron configurations. You may remember doing off-ball diagrams in chapter 5 and drawing your little arrows to figure out how to write electron configurations. And remember I said those were training wheels, and I'm actually going to take them away. And this is the part of the course where we take away the off-ball diagrams and learn how to do them just by looking at the table. So here's the electron configurations for everything in group 1. Do you notice something about how they end? You can see they all end in S1. If we look at group 2, we can see that they all end in S2. So there's a pattern emerging here. This should really include helium, but it fits better in group 18 because it has the properties of noble gases and it has a filled outer level of electrons. But it would end in S2, so it is also in the same category of elements here. So the groups 1, 2, and also helium are what we call the S block. The alkali metals all end in S1, and the alkali earth metals all end in S2. So this area of the periodic table we are now going to call the S block. So I want you to label this in your notes or on your own reference table. Draw a block around it just like I have here and label it S. Okay, let's look at group 18 here, the noble gases. You can see besides helium, they all end in P6. And they're the 6th element over on this side of the periodic table. So this is what we call the P block. From boron over the neon and on down, this is the P block. And you can number them P1, P2, P3, P4, P5, P6 across the top. This doesn't include helium because helium only has one sublevel and it only has 2 electrons in it. So here is the P block on your table, 13 through 18. Next we have the D block, which are the transition metals, and you can number them across the top, but there's a little strange twist here, and we talked about this back in chapter 5. It goes D1, D2, D3, D5. Remember, there's no such thing as a D4. We steal an electron from the S sublevel to make the D sublevel half filled because chromium and everything below it is more stable that way. And then we have another D5, D6, D7, D8, D10. Remember, we do the same thing. We steal an electron from the S and fill the D sublevels with 10 because it's more stable that way than with 9. And then another D10. So please label this as well, just as I have in this diagram here. And this zone, 3 through 12, the transition metals, this is your D block. Next we have the F block, or the inner transition metals, and you can number them right across the top, F1 through F14. I will probably never ask you to do an electron configuration of an inner transition metal. It's just too many electrons. It'd be a long process to write that out. But if you're curious, this is how they're numbered, and they are located, of course, below the main table. You can label that F block. So here we are again. Here's the whole thing. S is groups 1, 2, and it technically includes helium. P is groups 13 through 18. The D block is 3 through 12, and the F block is the inner transition metals below the table. So each row or period on the table is actually the energy level for the S and P orbitals. So you can just go down the period, and this is the energy level or principal energy level, or you can think of it as electron shell that the S and P sublevel, the S and P electrons are in. The d orbitals fill up one less than the period number, so you can't just follow the period number on these other ones. If you're down in an element in the transition metal land and you're filling up the d orbitals, you need to remember that the levels fill up one less than the period number, so that the first d is the 3d even though it's in row 4. So here we are, row 4. This is where the transition metals start with element 21 here, but we would start filling electrons in the 3d sublevel. Below it would be the 4d, then the 5d, then the 6d. The f orbitals start filling at 4f, so 2 less than the period number. So the first inner transition metal here, number 58, if you follow these lines, you can see it actually belongs here in period 6. But even though it's in period 6, and the row below it is in period 7, they fill up 2 less than the number. So this would be 4F sublevel, and the bottom one would be 5F. Okay, so you should have a diagram like this somewhere in your notes or on your own reference table, and we're going to use this, and we call it the spdf block system. I'm going to show you how to get electron configurations without filling out an off-ball diagram. So let's start easy. Hydrogen. So hydrogen is in period 1, so we would write 1. It is in the S block, so we'd write S, and it has 1 electron, and that electron is in the S sublevel, so it would be 1. So the electron configuration would be 1s1. Okay, if we were going to do helium, also in the first period, so it gets a 1. Helium is part of the S block, so we write S, and it has 2 electrons, so we write a little 2 there. Okay, let's go a little further. So beryllium has all of those electrons, so we always start at the beginning. We start in the first principal energy level, 1, and it has both electrons in that first sublevel, so we'd write S2. It has the same electron that hydrogen has, and it also has the same electron that helium has. Okay, then we transition down to principal energy level 2. So in principal energy level 2, it has electrons in the s orbitals because we are still in the s block. So it would have the third electron that lithium has, but it also has one more. So we would write 2s2. So there's the 1s1, 1s2, 2s1, 2s2. So that's beryllium. 1s2, 2s2. Next we have neon. So neon has the 1s2, just like helium has, and then we start filling in the 2s. Remember, we start from the bottom and go to the top energy levels. So we fill in the 2s2. Okay, that gives us where we were with beryllium. Now we are over here. Now we start filling electrons in the p sublevels. So this would be still the second shell. Okay, we follow. This is the period number 2. So we'd write 2. And we'd write P because we're in the P sublevels, and we have 1, 2, 3, 4, 5, 6 electrons in that sublevel. So the electron configuration would be 1s2, 2s2, 2p6. Okay, let's take it further to potassium. So we start at the beginning always. So 1s2. Now we're down here. 2s2. Okay, now we're over in the P block. 2p6. Now we're back to the third principal energy level, also in the S block though, so 3s2 will bring us to magnesium. Now we are in the P block once again, but in the third principal energy level, so we write 3p, and we have all 6 of those. And now we are in the fourth principal energy level, back in the S block, we write 4s1. And there's the configuration for potassium. Next we have titanium. Titanium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That brings us to here. Calcium, now we are into the D block. So remember, the D blocks fill up 1 less than the period number. So even though we're in period 4, we would write 3D. And we have 2 electrons in the 3D sublevel. Next we have chromium. So chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Remember, to half fill this sublevel, we're going to take 1 electron from the 4s to put it in the 3D to be half filled, 3D5. So that's a little exception. You always need to be on the lookout for any time you would get 3D or any D5, D4 or D9. Okay, let's do one more. Bromine, 1s2, bring us to helium. 2s2, bring us to beryllium. 2p6, bring us to neon. 3s2, bring us to magnesium. 3p6 would bring us to argon. 4s2 would bring us to calcium. Now we are in the D block again. Remember, we fill up one less than the period number, so 3D, and we have all of them, which would be 10, would bring us to zinc. Now we are back in the P block, and we are still in the fourth principal energy level, so we write 4p, and we have 1, 2, 3, 4, 5. 4p5. So, in summary here, knowledge of the spdf block system will allow you to write the electron configuration for any element just by looking at the periodic table. Now, I know you probably like doing off-ball diagrams because they were easy, but I promise you this will get easier with practice and it will save you a lot of time. Remember, when we're doing this process, always work your way from the beginning of the periodic table. Start with hydrogen and work to the element that you're trying to write the configuration for. The period number is the energy level for the S and P sublevels. It'll tell you where to start. But remember, the d orbitals start filling up one less than their period number. Again, I know this is a little tricky and might be a little intimidating at first, but I promise you with enough practice you'll get really good at this.